Now let's take a look at top boundary nodes, which are represented in green. So we're excluding the corner nodes because we'll talk about that later on. So all these green nodes, we can select one of them as our control volume, and then we have our east face, west face, north face, and south face, and also the point of interest is TP, TE, TW, TN, and TS. But in this case, TN doesn't exist because there's no node to the north of the point TP. So with that being said, now we can rewrite our governing equation for this specific node. So like what we said, Tn doesn't exist. At the same time, our top boundary is an insulated surface. Basically, that means there's no heat flux going through the north face. So that helps us to eliminate the third term in our equation because that's applied to the north face. So now if we rewrite our equation into the coefficient form, we can easily recognize that the Tn form is gone. So now if we rearrange this equation, we get this coefficient form in terms of Tp, Tw, Te, and Ts without Tn. Now moving on to the bottom boundary nodes, which is also represented in green. So the one on the left and the one on the right, these are considered corner nodes as well because they are bounded by two surfaces. So now if we draw a control volume around it, and then we also have east face, west face, north face, and south face, and TP, TE, TW, TN, and TS. Very similarly, in this case, TS doesn't exist because there's no point to the south of TP. So now if we look at our equation, we can simply eliminate the last term because that's applied to the south face because the boundary is insulated at the south face, so that means there's no heat flux from the south. So now if we rearrange this into our coefficients form without having TS, and then we can rewrite this in terms of TP, TW, TE, and TN.